Hey sixth graders, so today we are going to learn something brand new, which is called a box plot. So this is one of the last types of data we are going to do. But with box plots, we need to know that there are 5 pieces in our box plot. So we are going to label our 5 pieces. And we are also going to think about the fingers on our hand. We have 5 fingers, so that can make our box plot. So the first thing on a box plot that we are going to label is this very far end. So this right here, this is the minimum, okay? And that means that is the smallest point on my box plot. So if you follow that down, that is a 2. So my minimum is 2. Okay, so on the opposite side of our box plot, what's the opposite of a minimum? That is called a maximum, okay? So the biggest number that I have, if you follow that down, is a 14. Okay, so those are pretty self-explanatory, the minimum and the maximum. And we also already know what this part is called in the middle. What do we call what's in the middle? The median. So that line is going to be the median. So wherever that line is inside the box is our median. And on this one, that is an 8. Okay, because it's in the middle. And then now we are actually going to look at the box. So notice we have our box right here, and then we have the 2 pieces on the sides. So the 2 ends of the boxes are important, okay? We have this end. This is our Q1 because it's in the middle of the median and the minimum. And then therefore on the other end of our box, this would be my Q3. So my Q1 is 5 and my Q3 is 11. So 5 and 11. So those are the 5 pieces of a box plot we can label. Make sure we label those. The last thing that I want to point out on a box plot is notice that it is broken into 4 pieces. So we have this piece right here, the line. We have this side of the box to Q1 to median. We have this side of the box, and then we also have this piece. So since our whole box plot is split into 4 different sections, they are a percentage. So this section from here to here, this would be 25% of my data, okay? And then from here to here, so from Q1 to median, this is another 25% of my data. And then from the median to the Q3, that is 25% of my data. And then lastly, from Q3 to the end of the maximum, that is 25%. So if you notice, all of those percents give us the entire 100% of the whole box plot. So that will help us answer some questions. All right, let's go through and answer some questions. So it says label the box plot below. So we have our 5 pieces, okay? We have our minimum, and I'm gonna put min for short. We have our maximum, I'm gonna put max. Median is that line in the middle, and then we have Q1 and Q3. So now that I have those labeled, I can answer any of my questions. It says find the following. It wants range. And we just have to remember what range means. Regular range. That is my big minus my small. Or in box plot language, my max minus my min. So if I go to my max, that's 100. So 100 minus my small is 75. And 100 minus 75 is 25. So what that tells me is that from here to here, we are covering 25 numbers. Okay, and then it wants interquartile range, IQR. Hopefully we remember that is Q3 minus Q1 in order, matters, and subtraction. So Q3 would be here. So I have a 90 and a 95. So that would be really close to, like, let's say 92. So Q3 would be 92. Okay, and then my Q1 is real easy. It's just 80. Okay, So let's do 92 minus 80. That would give me 12. So what that tells me is between here and here, I am covering 12 numbers. All right, this next question, it says the list shows the growth in centimeters of 12 plants during 1 week. So we have a list of numbers right here, and then they want us to see which box plot best displays a summary of these data. So they want us to take the list and figure out which box plot would work. So to do that, I need my 5 numbers. So just looking at my list, what's my minimum number? What's the smallest number in my list? It's a 6. So if I look here, is my minimum at 6? Yes, it is. My minimum is at 6, minimum 6, minimum 6. So that does not help me get rid of anything yet. So now let's do the maximum. What's the maximum? It would be 14. Okay, that would be here. So that's good, 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 good. So the next thing we can find is the median, and I would have to actually start marking stuff out. So let's go for that. So 6, 14, 7, 11, 7, 11, 8, 10, 8, 9. And this is where some of us are getting stuck. Let's double check. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have 2 numbers in the middle. And when we have 2 numbers in the middle, my median is actually in the middle of 8 and 9. What's in the middle of 8 and 9? 8.5. If you don't remember, you could add together and divide by 2. So my median has to be at 8.5. Remember, that's the line in the middle. So on A, that is a 9, not an 8.5. So that is out. So B, that line, that could be an 8.5. Now, I do want to point out, the median does not have to be in the middle of the box, because some of y'all might be like, but Miss Cups, it's not in the middle. It doesn't have to be, okay? Just our previous examples did. I am looking for 8.5, and it is indeed at 8.5, so that one is good. C, again at 8.5. D is again at 9, so that one is out. So now we're between B and C. So the next thing I can find, I could do, let's find Q1. So remember, we are going to ignore everything over here, and we are going to find the median of this. So now I'm going to use my mark outs in the opposite direction. So what I mean by that, like my 6, I'm going to go this way now. And notice this 8 right here still counts. So then 7, 8. So I have 2 marked out on each side, so my median's technically going to be between 7 and 8, which is 7.5. Again, you could add and divide by 2. So that means I need this side, sorry about that, I need this side of the box. So that is Q1. That one's an 8, and that one would be a 7.5. So my answer would be C. All right. Let's go to this next one. So students recorded the amount of liquid and fluid ounces each of them drank in 1 day. The box plot shows a summary of the results. So let's label what we have first. So remember, we have minimum, we have maximum, we have median, Q1, and Q3. Okay, so let's actually answer the questions. So it says, which statement best describes these data represented in the box plot? So when it says best describes, it means which one's true. Okay, so which one of these is true? All right, so A, half of the students drank from 78 to 114. So half. So let's go back to the front of our notes. We talked about percents. How much percent is half? It'd be 50. So if we need 50%, we would need 2 pieces. So that could be these 2. Let me use a different color that might help. It could be these 2. It could be these 2. Or it could be these 2. So it doesn't necessarily matter which 2. It just needs to be 2 pieces of our box plot, okay? So when it says half on a box plot, we need 50%, which is 2 pieces of the box plot, okay? And it specifically said 78 to 114. So let's look at the number line. Where about would 78 be? Okay, so let's see. I have this line right here in the median. Could that be a 78? So between 72 and 84. I'd say so. That could possibly be it. And then 114 would be possibly, could that max be 114? I'd be okay with that. And then, so essentially it is saying that this part and this part of the box plot are in there. So if we have two pieces of the box plot, we have this 25% and this 25%. So even if they're not the same size, they still represent 25%, and 25 is 50. So that actually would be my answer. Okay, if we were to look at B, it says the greatest number of students drank from 30 to 78, and 30 would be this piece, up to 78, which would be this, and this, which would be the other half. And half is not the greatest, it's half, it's the exact same. So that one's out. C, the data represented 78 students. We have no idea how many students there are. All I can tell you is that we have a minimum and a maximum and the median, but I can't tell you how many people there are. That is definitely a no-go. And then again, the mean, we would have to add all of our numbers, which means we would have to have a list. Like we would have to have like a 30, 32, 60, and we can't do that with the box plot. So that is also out. All right, this is our last one, almost done. The box plot summarizes the attendance for the spring music and the fall musical. Each musical was performed for 6 evenings. So notice we have 2 box plots. We have spring and we have fall. So when we're reading, we have to pay attention to which box plot they're talking about. Which statement best describes, the data represented in the box plot? So best describes is true. All right, so it says the range, remember range is big minus small, and attendance for the fall, so we want this one is 45. So range is big minus small. Oh, sorry, I was looking at the wrong one, is 85. So we want big minus small for fall. So my big would be right in between 220 and 230, so that'd be 225. And my small was actually right on 140, so we would need to subtract those two, okay? And 225 minus 140 is 85, so that is indeed a possible answer, okay? So the next one would be interquartile range, which would be Q3 minus Q1. This is for spring, would be 45. So now we're looking at spring, and I want Q3, which would be 195, and Q1, which would be 135. And if I subtracted those, I would get 60, not 45. So that is not true. And then the other two are half, which would mean 2 pieces, but just for the sake of time, A is our answer. So make sure you label your 5 pieces. Half is 50%, you need 2 pieces, and you can go from there.